Welcome. In this webinar we will learn about the Tinkercad Circuits tool. Tinkercad Circuits is a free online platform that allows you to design, program and simulate electronic circuits virtually. It is especially useful for students, educators and electronics enthusiasts, since it does not require additional hardware and offers a wide variety of components and tools to experiment with. First, let's answer the question why Tinkercad Circuits is interesting. 1. Accessibility. Being online, it is available on any computer or device with an internet connection, which facilitates access from anywhere. Therefore, it is very interesting because you can work from home without having to physically be in your school's laboratory. 2. Interactivity. It allows designing, first, and then simulating circuits in real time, which helps to understand how the electronic components work without having to physically assemble them. 3. Educational. Ideal for learning basic concepts of electronics and programming with Arduino and microbit. 4. Safety. Being a simulation, it eliminates the risk of damaging real components that can burn, for example, by using inadequate voltages. It prevents these components from being lost and allows tests to be carried out quickly in the simulator. 5. Creativity. Tinkercad Circuits offers a platform to experiment and create innovative projects without physical limitations. Let's review the first steps in Tinkercad Circuits. The first thing is to create an account in Tinkercad on the website www.tinkercad.com and register with your email. If you already have an account, you can start the session. It is also possible that you can access through a number that your teacher has given you in class. As we mentioned in previous webinars, Tinkercad allows you to design parts in 3D, but today we are going to access the circuit section. If we click on the Create button, we will select Circuit to start a new project. In the right column, you will see several components. To make it easier to locate the component you are interested in, you have at your disposal the filtering by basic, Arduino, microbit, circuit assemblies and all that allows you to list all the components. For example, we select Arduino, and several preset configurations are displayed. We explore other filters such as microbit, or circuit assemblies so that you become familiar with the filtered groups. If we go back to Arduino, we will select an Arduino Uno and you can either click and place it in the graphic area. We review some of the menus that you have available at the top. For example, you can list the types of cables. And you also have the option to select the color of the cable from the 12 available colors. For example, we select the orange color with the normal cable option, and we see that it is possible to start connecting the available elements. By clicking several times, we can design our cable in an assisted way and connect it where we are interested. The graphical format can be modified through the small circles that make up the cable path. You can explore and familiarize yourself with the placement of cables, which as you can see is assisted because it detects all the points where the cable can be connected graphically. At any time, you can delete the selected element. To do this, you can use the delete key on your computer or use the trash can icon available at the top. You can select any of the elements available in the graphical area. As long as you have the cable option activated and click on a starting point, the cable design will start to be drawn by moving the mouse. Explore these features. As you can see, they are very intuitive and easy to use. Let's create our first circuit design from scratch. To do this, we will select an Arduino Uno R3. When we place the element in the graphical circuit design area, we see that we are given the option to name the element if we wish. In this case, we will leave the default name, which is 1. We have some features in the icon bar at the top, such as the rotate feature. This way we can rotate our Arduino board 90 degrees. This makes the labels with the board's indications easier for us to read. Now we place another element, a breadboard small. We select the type of cable, which by default is normal, and we make the connection from the 5-volt pin of the Arduino board to the breadboard in a cathode pin or positive pole. When the connection has been made, you can double-click on the connector cable and create a control point that will allow you to design the cable in the way you need. Add as many control points as you want to make your design look aesthetically pleasing. Once the first red wire is finished, we are now going to connect the GND pin to the breadboard's anode or negative pole. GND is the abbreviation for ground, and in electronic and electrical circuits, it refers to a common return path for the current to the power source, thus allowing the circuit to be completed. The wire from the GND pin to the breadboard's anode is changed to black. Note that when I move the mouse over the breadboard over the pins, the entire line of pins is highlighted in green, which means that they are connected, and therefore it doesn't matter whether you connect the wire to the positive pin in position 1 or to any of the positive positions up to position 30. The same goes for the negative line of pins on the breadboard. Now we are going to connect the other part of the breadboard to enable it fully. For this we use the black wiring for the anode or negative pole and the red to connect the cathode. Make sure to use the same color terminology to identify wires so that it is easier to identify circuits in the future. Using these conventions makes circuit designs and understanding easier. Now we are going to place an LED to flash. To do this, we select the LED component and place it on the graphical screen. We can define the color of the LED by displaying the color menu. For example, we select the color blue. We can rotate the LED and place it on the breadboard. Now we place the wires from pin 13. The next step is to place a resistor. Resistors are used in electrical circuits to adjust current and voltage, in the same way that taps are used to adjust the flow of water from a tap. They can be used not only to control the flow of current, but also to distribute voltage in a circuit. As you can see, it is possible to change the value of the resistance and its magnitude. Resistance is a measure of the opposition to the flow of current in an electrical circuit. Resistance is measured in ohms, which are symbolized by the Greek letter omega. They were named ohms after George Simon Ohm, 1784 to 1854, a German physicist who studied the relationship between voltage, current, and resistance. For now, we are going to leave the resistance value by default, and we are going to place the resistor on the breadboard. At this point, you can stop the video and study the circuit we have built. If you are with your classmates, it is a good idea to discuss this circuit. What do you think? Will it work? How many of you think it will? Is there anyone who is against it and believes that it will not work? Well, let's check it. To do this, we can simulate the result by clicking on Start Simulation. Wow, the Arduino board has been connected, but it seems that something is not right. What a disappointment! Let's disconnect the simulation and review the code by clicking on the Code button. You have three options to review the code: viewing the blocks option, the text-only option, or the blocks plus text option. When you change from blocks to text, you will get a message asking if you are sure, as it warns you that you may lose the block coding if you change. This reminder will be useful in the future. As you can see, each change carries a warning. We close the code editor for now, as there is nothing strange at this point. If you have already discussed it in class with your classmates, you may have already detected the problem. If not, pay attention to the changes we are going to make to our circuit. The first thing we are going to change is the position LED. We also modify the red wire so that it is located on another pin. You can pause the video again. Do you think it will work now with these simple changes? Let's watch the simulation. Voila! It works. We see that this configuration does close the circuit with the LED and allows it to light intermittently. We will stop the simulation and now review the coding. We can easily modify the time that the LED will be on and the time it will be off. You can see the value in milliseconds. In this case, it is 1000 milliseconds, or what is the same, 1 second. We are going to change these values. We modify the figure from 1000 to 2500 milliseconds in both cases. We now check the changes by activating the simulation. We can see that now the time that the LED remains on is 2.5 seconds, and it also remains off for 2.5 seconds or 2500 milliseconds. We close the simulation and now we are going to make the LED turn on and off faster. To do this, we will change the values to 500. In this case, the blinking is faster, changing from on to off every half second. We have seen that when the legs of the LED were on the same line of the breadboard, it did not work. It is important to pay attention to these connected lines of the breadboard to learn them. Now we are going to place a new red LED. We add the resistor. Keep in mind the value. In this case, we are going to place the two 200 ohm resistors. Observe how the color coding of the resistor changes when its value changes. You must consult and know this resistor coding to know the intensity they will provide. We check that the resistors are correctly located and complete with the cable that we will connect pin 12 of the Arduino to the anode of the new red LED. We activate the simulator. We observe that only the blue LED works. We go to the coding to observe the code. Now we are going to look at something more than the values. We have two functions. The setup function initializes the LED built-in as output, and then, within the loop function, the LED turns on and off at intervals defined by the values that we have already seen how to change. But this code needs the second LED to be identified. Therefore, we are going to copy the code first and then identify each LED based on the pin from which it is connected to the Arduino board. Therefore, we will have the values 13 and 12 to identify each LED. We make the loop copy for the second LED and activate the simulator. As we have copied the first state twice for the red LED, you can see that it does not change intensity and is always in high mode, that is, always giving light. By changing high to low, we have that both LEDs turn on and off. If we change the values in milliseconds, we can see different results. are going to change the color of the red LED also to the blue color. Imagine this coding for the colors of a police car with the blue lights on alternating their operation. With this LED dynamic and loop operation, what other alternatives can you think of? Now we change the text coding to block and text again. The warning tells us that it has not saved the changes in the text coding. We are interested in seeing now the block coding, which is simpler, but it is also convenient to learn the text coding, which will allow you to improve your training for the future. Do you dare to do the same exercise coding it with blocks? You can stop this video now and try it yourself. Now we are going to make the changes in the block programming. To do this, we are going to change the necessary blocks that allow us to identify each LED based on the pin where they are connected to the Arduino board. The blocks that we are interested in deleting will be deleted through the trash that appears. When we have the two LEDs referenced in the blocks, we are going to simulate to check what happens. According to the coding, the LEDs wait 1 second to activate, but once activated, they are always bright. This is because the coding is always high. If we want them to blink, we must return to the coding and activate the low option in both LEDs. And we activate the simulate option. As you can see, Tinkercad updates the text coding based on the blocks. So you can see how block and text coding give the same result. Which of the two methods seems easier to you? Now take advantage of your knowledge and provide combinations of colored LEDs in different exercises. I hope you liked this basic tutorial on Tinkercad circuits. I encourage you to continue exploring the possibilities. Thank you very much for your attention.